Hi, this is Mrs. Basin, and this is going to be a review of net ionic equations. So the way we're going to do this is we're just going to work through some different examples, and I will walk you through each one as we go. So our first one is lithium metal is added to water. So we're going to start out by writing out our reactants. So lithium is Li, and that's added to water. And then once you have your reactants, you're going to look and see if you can figure out what type of reaction it is so that you can predict the products. So this is a single replacement reaction, but it's a special type of single replacement. This is a single replacement when you have an active metal, which means anything in group 1, and your heavy group 2 elements starting from calcium down. When an active metal reacts with water, you get hydrogen gas produced. And then your other product is the hydroxide of the metal. So whatever that original metal was, it's going to be that metal hydroxide. So in this case we have lithium hydroxide. Then our next step is to go back and balance it. So I need a 2 there, 2, and a 2 here. So that balances our equation. After we've done that, now our next step is going to be to go through and show everything as ions in solution if possible. Okay, so our first substance, lithium, is going to stay the same because that's a solid. Water is a pure liquid, so we leave that alone. That one also stays the way it is. Hydrogen's a gas, so we leave that. Now when we get to lithium hydroxide is a strong base, so in solution it will dissociate into its ions. So we're going to show this as 2Li plus 2OH minus. And at this point there's nothing that can cancel out, so this would then be our overall net ionic equation for lithium metal is added to water. Our next equation is we have a solution of copper 2 chloride, and that is added to a solution of sodium sulfide. So again, I'm going to start by writing out my reactants. So copper 2 chloride is going to be CuCl2, and my other reactant is sodium sulfide, which is Na2S. And then from that, I'm going to predict my products. So if I look at this, I have 2 ionic compounds. So these are going to switch places. So this is a double replacement reaction. So on the other side, I end up with sodium chloride and copper sulfide. So our next step now is to balance, and in this case the only thing we have to do to balance it is to put a 2 right there. Since we know this is double replacement reaction, we know that one of our products is going to be a precipitate, so then we would refer to our solubility rules to figure out which one is a sulfate. So in this case, sodium and chlorine, we know both of those are soluble, so that means that our copper sulfide is going to be our solid or our precipitate. Next step now is to go through and see what forms ions in solution. So since we started with 2 solutions over here, we know those are both going to dissociate. So we have Cu plus 2 Cl minus. Our sodium sulfide breaks down into 2 Na plus S minus 2. And again, the way we're doing this is this compound splits back up into its ions. So copper goes back to its plus 2 charge. Chlorine, there's 2 of those, so that's where we get our 2 Cl minus. Sodium, this subscript 2 here, goes to the front, so that shows that there are 2 sodium ions, and then sulfur minus 2. On the other side, sodium chloride we know is soluble, so that's also going to dissociate. So we have 2 Na plus 2 Cl minus. And this 2 in the front goes to both of those ions, so there's 2 Nas and there's 2 Cls. And then our solid we leave as CuS. Our next step now is to look and see if it's possible to cancel anything out. So if we look at what we have here, we can cancel out our 2 Na pluses and we can cancel out our 2 Cl minuses. So then we're going to rewrite what's left to show what our net ionic equation is. So we have Cu plus 2 plus S minus 2, which gives us CuS. So that would then be our net ionic equation. Okay, our next reaction is aluminum metal is added to a solution of copper 2 chloride. So again, we're going to write out our reactants. So we have aluminum plus copper 2 chloride, which is going to be CuCl2, and then we predict our products. So our reactants again, aluminum plus copper chloride. This is a single replacement reaction. So aluminum will take the place of copper because that's the element that it's most like, or it has a positive charge. So copper will be formed in the solution, and then we'll be left with aluminum chloride, which is going to be AlCl3. Okay, next step, again, before we move on, is to balance it. So to balance this one, we need a 2 in front of the Al, 3 in front of our copper chloride, gives us 3 copper and 2 aluminum chloride. Then we move on to our next step, which is to now look at what forms ions in solution. So our aluminum is a solid, so we're going to leave that the way it is. Copper chloride is a solution, so this is going to break apart. So we have 3 Cu plus 2 plus 6 Cl minus. Because we have this 3 here times that 2, we have a total of 6 chlorine ions in solution. And that gives us 3 copper on the other side. And then aluminum chloride on the other side is also a solution, so that's going to dissociate. So we have 2 Al plus 3 plus, again, 2 times 3 gives us 6 Cl minus. Next step, go through and cancel out anything on both sides. And again, we call these our spectator ions. So these are things that are unchanged over the course of the reaction. So our 6 Cl minuses are our spectator ions in this case. And then we rewrite our final equation. So we have 2Al plus 3 Cu plus 2 gives us 3 Cu plus 2 Al plus 3. This particular equation shows us why it is so important to write our charges and be extra careful when you're going through and writing out your ions in solution, because a Cu plus 2 does not cancel out a neutral copper atom. So they have to be the exact same substance and charge. So if you're not careful when you're breaking these apart in the very beginning, sometimes you end up canceling out things that should not cancel each other out. So here in your final equation, you end up with aluminum plus 3 Cu plus 2 gives us 3 copper plus 2 aluminum plus 3. Okay, our next one we have is magnesium metal is added to nitrogen gas. So magnesium metal is just Mg, and it's added to nitrogen gas, which is N2. That's one of our diatomic molecules, or the ones that we call our Brinkelhoff molecules. And since you have an element and another element, the only thing that can happen here is for these two to combine in a combination or a synthesis reaction. So we end up with Mg3 N2. Then we need to go back and balance it. So we need 3 magnesium to balance that out. And then our next step is to look and see if there is anything that ionizes in solution or dissociates in solution. So we're going to rewrite it. So 3 magnesium, it's a solid. Nitrogen is a gas. And then, like we said in class, usually these synthesis reactions or combination reactions, these are solids. So this magnesium nitride we would leave the way it is also. So for this one, nothing cancels out, no ions in solution on this one, so this is our balanced net ionic equation. Our next equation is methane gas is burned in air. So methane, again, we talked about this in class, how you can actually go through and figure out the formula. Until later on in the year, I would tell you what methane is. So methane, you may already know, is CH4. Meth means there's one carbon. The ANE means they're all single bonded, so CH4 is our compound for that one. It's burned in air, which means it's reacting with oxygen. So you should recognize this one as a combustion reaction. And we know when you have a combustion reaction, our products are CO2 plus H2O. Our next step is to go through and balance. This is a fairly simple combustion reaction to balance. We only need a 2 in front of the oxygen, and we need a 2 in front of the H2O. Next, we're going to look and see if anything ionizes or dissociates in solution, which we know in this case these are all gases. So we would just rewrite this. CH4 plus 2O2 gives us CO2 plus 2H2O. So in this case, this is our balanced equation. Okay, our next reaction, and we're almost done here, this is our second to last one. We have equal volumes of 0.1 molar sulfuric acid and 0.1 molar potassium hydroxide, and these are added together. So we're going to go ahead and write out our reactants. So we have sulfuric acid, which is H2SO4, and potassium hydroxide, which is KOH. And if we look at this, this is an acid-base reaction. So we know that we're going to end up with water. So one of our products is going to be water. And then our other product is going to be K2SO4. Okay, so this basically acts like a double replacement reaction. Next step is to balance this. So to balance this, we need a 2 in front of the KOH, and we need a 2 in front of our water. Now we're going to go through and look at what forms ions in solution. So our first substance, H2SO4, is a strong acid, so we're going to end up with 2H plus and SO4 minus 2. Our KOH is a strong base, so that will also break apart. So 2K plus, 2OH minus. Water is a liquid, so that stays the way it is, 2H2O. And then our potassium sulfate also is a ionic compound, so that's going to dissociate. So we have 2K plus and SO4 minus 2. Next step on this one, look and see if anything cancels out, if we have any spectator ions. So in this case, our SO4 minus 2 is the same on both sides, and then our K plus, it stays unchanged. And again, spectator ions are ions that are unchanged over the course of the reaction, so they have not changed from one side of the reaction to the other. And then our final thing to do here is to rewrite this, so 2H plus, 2OH minus gives us 2H2O. And we could even rewrite this again and eliminate those two so that we end up with just H plus OH minus yields 2H2O to show it in, we could think of it as reduced form. And like we talked about in class, anytime you have a strong acid, strong base reaction, your overall reaction is going to be the formation of water. Okay, our last example is dilute sulfuric acid is added to a solution of lithium hydrogen carbonate. So again, we're going to start with our reactants. So we have H2SO4 plus lithium hydrogen carbonate, which is LiHCO3. So hydrogen carbonate is HCO3. And then we're going to look at what our products are going to be. This is a special type of reaction. So this is an acid reacting with a carbonate. And when you have a carbonate, it can be HCO3, it can be a hydrogen carbonate or a bicarbonate, or it could just be the CO3 minus 2 by itself, the carbonate by itself. So acid and a carbonate reaction give you CO2 and H2O, and then the other product is whatever salt is left. So in this case it would be the lithium sulfate. So I would have Li2SO4. So again, this is an acid with a carbonate. You end up with CO2, H2O, plus whatever else, whether ions are left that form that other salt. We're going to balance this one. So we need a 2 in front of the lithium hydrogen carbonate, a 2 in front of the CO2, and another 2 in front of the H2O. Next step, go through and look at what forms ions. So our H2SO4 is a strong acid. So we have H2H plus SO4 minus 2. The lithium hydrogen carbonate is also a solution, so that's going to split up. So we have 2 Li plus 2 HCO3 minus. Carbon dioxide is a gas, so we leave it the way it is. Water's a liquid, so that stays. And then our lithium sulfate is an ionic compound, so that's going to also dissociate in solution. So I have 2 Li plus, and I'm going to have to go down to the next line here for this one, and SO4 minus 2. Last step, go through and see if they're spectator ions. So in this case, my lithium ions cancel, my sulfates cancel, and I'm going to write what's left. So I end up with 2H plus 2 HCO3 minus gives me 2 CO2 plus 2 H2O. So then that again is my net ionic equation for that reaction.